Skill Practice 20. Question 1. Since the element and polyatomic ion in this compound have the same charge, there is no need for subscripts. Therefore, the symbols of the element and polyatomic ion just need to be added together to create the formula. Question 2. In order for the molecule to have a zero charge, there needs to be 3 sodium ions for 1 phosphate ion. Therefore, sodium needs a subscript of 3 following it before the polyatomic ion phosphate can be added to the formula. Question 3. The molecule will have a zero charge only if there are 2 hydroxide ions for the 1 magnesium ion. The hydroxide ion needs to be put into parentheses so that the subscript applies to the whole polyatomic ion. Hydroxide needs a 2 after the OH in parentheses so that the formula is then correct. Question 4. The ic ending in sulfuric means that the sulfate polyatomic ion is present in this acid. Knowing which polyatomic ion is used helps you know how many hydrogen ions there need to be in the acid. For 1 sulfate ion, there is 2 hydrogen ions, so there needs to be a subscript of 2 after the H before you can connect the 2 different ions to create the formula. Question 5. Since sulfur has a charge of -2 and ammonium only has a charge of +1, there needs to be 2 ammonium ions in the molecule. After the polyatomic ion is added to the formula, parentheses need to be added around it so that the subscript of 2 that is needed applies to the whole polyatomic ion in the formula. Since oxygen has a charge of -2 and potassium has a charge of +1, there needs to be 2 potassium ions for every oxygen one, meaning that there needs to be a subscript of 2 following potassium symbol in the formula. Oxygen symbol then follows the 2. Question 7. Both aluminum and phosphate have a charge of 3, so there doesn't need to be any subscripts after either of the ions, and aluminum symbol and the polyatomic ion can be just added together to form one molecule. Question 8. Just like the last problem, both sodium and hydroxide have the same charge, so there doesn't need to be any subscripts after the Na or OH, and they can just be added together to form the formula. Question 9. Since acetic ends with the ending ic, the polyatomic ion is acetate. Knowing that acetate then has a charge of -1 means 1 hydrogen is needed for 1 acetate ion, and there doesn't need to be any subscripts following either of the ions. The formula for acetate is then just added after the H. Question 10. Just like question 4, the polyatomic ion that is made into an acid ends in 8, because carbonic has the ic ending when the compound is named. Therefore, carbonate is the polyatomic ion that is being dealt with and has a charge of -2, so that means there is 2 hydrogen ions for the 1 carbonate, and a subscript of 2 needs to follow the H in the formula. Question 11. Knowing that Ca stands for calcium and the O is oxygen, it is also known that the molecule is an ionic compound. This means that prefixes don't need to be used, and you can name the compound just straight with the element names, except for that oxygen changes to oxide because it is the second element in the ionic compound. Question 12. Just like calcium oxide, BaCl2 is also an ionic compound because there is a nonmetal and a metal coming together. Even though the charges are different, that doesn't matter when naming this compound because prefixes aren't needed. Naming the compound is easy. First comes the name of the first element and then the second element follows, except with an ending of "ide" instead. Question 13. When naming an ionic compound with a polyatomic ion, the name is strictly the first element and the name of the polyatomic ion, so the name of the formula is potassium phosphate. Again, knowing the polyatomic ion helps a ton. When naming this compound, you must know that OH is hydroxide, and you just add that after the name of the element that comes first in the formula to name the whole compound. Question 15. Since there is a hydrogen atom